This video is for limiting reagent and percent yield. So we're going to talk about what a limiting reagent is and an excess reagent, and do some examples of that, and then talk about percent yield and do some examples for that. So we're going to start with limiting reagent. And our first few examples are going to be based around this chemical equation for the formation of ammonia. So this equation says 3H2 plus N2 goes to 2NH3. So what that really means for us in chemistry is that 3 moles of hydrogen reacts with 1 mole of nitrogen, and that produces 2 moles of NH3. Those are the exact stoichiometric relationships for that equation. So if we were to react 3 moles of hydrogen and 1 mole of nitrogen, we would get 2 moles of ammonia. But what if we react 3 moles of hydrogen with 2 moles of nitrogen? So this is where a limiting reagent problem comes in. When you have information about 2 different reactants, how many moles of NH3 are we going to produce? This one you can probably figure out in your head, right? That you're going to have extra nitrogen, because for every 3 moles of hydrogen, you only need 1 mole of nitrogen, so you have a mole left over. Okay? Let me just show you when you can't figure it out quickly, or when you start with grams, you're going to want to do this. Here's a way that works every time. So we're going to start with each of our reactants and assume that that reactant reacts completely. So if I have 3 moles of hydrogen, for every 3 moles of hydrogen, I produce 2 moles of NH3. So I would get 2 moles of NH3 possible if all 3 moles, of H2, reacts. So if all 3 moles of H2 reacts, we would make 2 moles of NH3. We're going to do the exact same thing for the nitrogen. If 2 moles of nitrogen reacts, for every 1 mole of nitrogen, you produce 2 moles of NH3. So if all 2 moles of nitrogen reacts, we would make 4 moles of NH3. So these can't both be right. And the one that's smaller, in this case, are 2 moles of NH3, has to be the correct answer. If I can only make 2 moles of NH3, I can't possibly make 4. Okay? I'll run out of hydrogen before that happens. So this is the correct product, the 2 moles of NH3. And the reactant that you started with is the limiting reagent. The limiting reagent limits the amount of product that you can form. The other reagent, or others in some cases, is called the excess reagent. So in this case, our 2 moles of N2 is the excess reagent. We would have some left over at the end of the reaction. Reagent is just another word for reactant. Okay, so the limiting reagent will produce the least amount of product out of possible reactants, and the excess reagent will be left over at the end. So let's do another one. We're going to do one with grams this time. So in this one, we're going to have 15.5 grams of hydrogen react with 60.5 grams of nitrogen. So we're going to figure out how many grams of NH3 can we produce. It's going to look exactly the same as the example I showed you before. I'm going to take 15.5 grams of hydrogen, convert that to grams of NH3. Then I'm going to take 60.5 grams of nitrogen and convert that to grams of NH3. So 15.5 grams of H2. First, we're going to convert to moles of hydrogen. So each mole of hydrogen is 2.016 grams. Now we use our balanced equation. For every 3 moles of hydrogen, we produce 2 moles of NH3, and 1 mole of NH3 weighs 17.034 grams. So typing that into our calculator will tell us the maximum possible if all 15.5 grams of hydrogen reacts. And we get 87.3 grams of NH3. Now we're going to do the exact same thing for the N2. 60.5 grams of N2, 1 mole of N2 weighs 28.02 grams. For every 1 mole of N2, you produce 2 moles of NH3, and 1 mole of NH3 is the 17.034 grams. So this time you get 73.6 grams of NH3. So that's our answer. The smaller of the two, okay? I can only make 73.6 grams with 60.5 grams of nitrogen. So once the 73.6 grams are made, you're out of nitrogen. The nitrogen is gone. That's your limiting reagent. So we don't use all of the 15.5 grams. That's in excess. We don't get to the 87.3 because we don't have enough nitrogen to get there. You don't have to do this the exact same way. There are other ways to figure out what the limiting reagent is. I like this way because it works every time. There's a nice pattern to follow. And generally, you want to find out the mass of a product, and that gets done while you're finding the limiting reagent. Oh, we just did this one. I'm silly, I apologize. So let's move on. Here's a new one. You can try this one. So if 18.1 grams of NH3 reacts with 90.4 grams of copper oxide, according to the balanced equation below, how many grams of nitrogen can form, and what is the limiting reagent? So you can pause the video and solve this yourself, and then push play again, and I'll solve the answer for you. Okay, so hopefully you've done this yourself. Now we'll do it together. So we're going to do 18.1 grams of ammonia, 90.4 grams of copper oxide, and we want to know how many grams of nitrogen. So just like I've been doing, I'm going to convert each reactant into grams of N2. So we have the same molar mass here, right? Our NH3. So 1 mole of NH3 is 17.034 grams. I can see that I made an error on my paper, so we'll recalculate that in a second. And then according to our balanced equation, for every 2 moles of NH3, there's 1 mole of N2, and 1 mole of N2 weighs 28.08 grams. So I have to recalculate because I wrote this wrong on my paper. So 18.1 times 28.02 divided by 17.034 divided by 2, and I got 14.9 grams of N2. So now we're going to do the other one, the 90.4 grams of copper oxide. Hopefully I got this molar mass right. So the molar mass of copper oxide, 79.55 grams. Is 1 mole of copper 2 oxide. Our balanced equation says that 3 moles of copper oxide produces 1 mole of N2, and 1 mole of N2 is 28.02 grams. And then for this one, I got 10.6 grams of N2. So this is our product. 10.6 grams of nitrogen can form, and the limiting reagent was the 90.4 grams of copper oxide. I want to take a minute to point out that the limiting reagent is not always the smaller of the two values, either moles or grams. And this is a perfect example. 90.4 grams is much larger than 18.1 grams. That doesn't mean it can't be the limiting reagent, okay, because things have different mole ratios and different molar masses. Okay. When we do these types of calculations with a limiting reagent or without, and you calculate the amount of product at the end, this is what's called a theoretical yield. So any of these types of stoichiometry problems that you're doing, when you calculate the grams of product that can form, that's the theoretical amount of products that can form. It's important to realize that that's not always the amount of product that you get from a reaction. There are side reactions that occur. There are other complications with experiments, filtration and separation of chemicals that remove or detract from your products when you do a chemical reaction. So you're actually going to get less product than your theoretical yield. And often we record this as percent yield. So the percent yield for a reaction is equal to the actual yield divided by the theoretical yield times 100. And as we just said, the theoretical yield is calculated. That's a calculated value using stoichiometry. The actual yield is either given to you if you're doing a problem, like a word problem from your textbook or on a quiz or a test, or if you do an experiment, right, this is your actual experimental yield. So we're going to calculate, we're going to do another limiting reagent practice and then calculate the percent yield. So we're going to look at the formation of methanol, CH3OH, it's methanol, which is formed from hydrogen and carbon monoxide, sorry. So when 8.60 grams of hydrogen reacts with 68.5 grams of carbon monoxide, 35.7 grams of methanol is actually produced. So here's our actual yield right here already, our 35.7 grams. Calculate the theoretical yield and the percent yield. So our first job, right, is to do our limiting reagent problem and find our theoretical yield. So let's start with 8.6 grams of hydrogen, and we're going to convert that into grams of methanol. So 2.016 grams is 1 mole of hydrogen. For every 2 moles of hydrogen, you produce 1 mole of methanol, and 1 mole of methanol is equal to 32.042 grams. So 68.3 grams of methanol. Or 68.5 grams of carbon monoxide. Again, we're going to convert to grams of methanol. So 1 mole of carbon monoxide weighs 28.01 grams. And our balanced equation tells us this is a 1-to-1 mole ratio. So 1 mole of carbon monoxide yields 1 mole of methanol, and 1 mole of methanol weighs 32.042 grams. So for this, I got 78.4 grams. So that's bigger, right? So this is our theoretical yield. Our 68.3. So to calculate the percent yield, we're going to do the actual yield. So 35.7 grams of methanol divided by the theoretical yield, 68.3 grams of methanol times 100%. So note here that your units are the same, right? So your percent yield has no units, okay? Because you have grams of product divided by grams of product. So I got 52.3%. So we made 52.3% of the expected amount of product. So I hope that helps you with the basics of limiting reagent and percent yield. We're definitely going to do some practice in class with both of those, but this should get you started. You can look at your homework assignments in the book. You can watch the video as many times as you want, and I'll see you in class. Thanks.